Welcome to Brain Unpacked. Ever heard you're strictly left-brained or right-brained? While popular myths often oversimplify this, there's real science behind how our brain hemispheres divide labor, especially for something as crucial as seeing the world around us. It's not about being just analytical or artistic, it's about your brain optimizing how it perceives everything. Think about this. When you look straight ahead, everything in your left field of vision is primarily processed by your right brain hemisphere. And what's on your right? That's handled by your left hemisphere. This is called contralateral processing, and it's a fundamental principle, extending even to complex mental tasks like attention and memory, managed by our prefrontal cortex. So why this split? It's all about boosting our perceptual capacity. Our ability to process visual information isn't limitless. By dividing the work, each hemisphere focuses on the opposite side of our gaze. This essentially doubles our brain's resources for seeing. It's a bilateral advantage that helps us avoid perceptual blind spots and prevents our attention from getting overloaded, especially when we're tracking multiple things or scanning for danger. If all our focus was on one side, we'd miss critical information on the other. Now, this hemispheric split is quite specific. It's mainly for spatial information, the where of an object. Other details, like an object's color or shape, are usually processed by both hemispheres. This shows just how sophisticated our brain is, selectively splitting tasks for maximum efficiency. But if there's this division, why don't we experience a weird visual jump when an object moves from one side of our vision to the other? Our brain has incredibly smooth handoff mechanisms. As an object nears the center of your vision, the hemisphere that's about to take over starts ramping up its activity. The hemisphere that was initially processing it stays engaged for a short while, even after the object crosses the midline. This overlap, lasting up to a second, ensures we see a continuous, unified world. There's a tiny processing cost for this coordination, but it's worth it for seamless vision. Interestingly, even in our advanced prefrontal cortex, this bias for contralateral processing of spatial information sticks around. The hemispheres can work quite independently for things like attention and memory. Studies even show we often remember more items if they're shown across both visual fields, engaging both hemispheres, rather than clustered on one side. What's more, individuals can differ in their perceptual capacity across their visual fields. Understanding these personal variations could be key in optimizing performance in visually demanding jobs or activities. From an evolutionary standpoint, this brain lateralization or hemispheric specialization is a big win. It allows for parallel processing. Maybe one hemisphere handles visuospatial tasks, while the other is dominant for language. This makes the brain more efficient and reduces redundancy. It might also help us multitask better and prevent the hemispheres from competing with each other when deciding on a response. Developmentally, this specialization isn't set in stone from birth. Young children might show more activity in both hemispheres for tasks that, in adults, become more strongly lateralized to one side. This suggests a gradual fine-tuning of our brain's amazing division of labor as we mature. In a nutshell, your brain's strategy of dividing spatial perception between its hemispheres is a masterclass in efficiency. It maximizes our ability to see, improves how quickly we process information, and boosts cognitive functions like attention and memory. While the hemispheres can act independently, they also coordinate perfectly to give us that seamless, unified experience of the world. It's a truly fascinating insight into how we're wired to understand our surroundings. Thanks for tuning in to Brain Unpacked.